Hi, everybody. I'm Corey Minton, Director of the Observability Strategist team here at Splunk, and I am excited to bring you another data deep dive for the Logitech McLaren G-Challenge, where Splunk partnered with our friends at McLaren and Logitech to bring data-driven insights to the Logitech McLaren G-Challenge competition this year. And for those of you who maybe don't know what the Logitech McLaren G-Challenge is, check out this quick video.
Let's take a look at our data-driven insight powered by Splunk.
Well, just like success in pretty much every sport requires a team, success in building the data-driven insights for the Logitech McLaren G-Challenge powered by Splunk took a team, and I'm excited to welcome Matt Moore to the stage. Matt, tell us a little bit about yourself.
G'day, Corey. G'day, guys. Matt Moore. I'm based out of the sunny Melbourne, Australia, but out of San Francisco at the moment. I'm an observability strategist here at Splunk and the resident data scientist for the observability strategist team. I'm an Aquarius, and I have a very smelly pet dog called Ruby.
That's fantastic. Well, we're just wrapping up a fantastic week here in San Francisco for the RSA conference, where Splunk is a top-level sponsor, and we're also excited to be bringing the McLaren racing experience to those participants here at RSA. Folks had a chance to sit down in a racing simulator and see their data brought to life using Splunk right there on the show floor. And it's really what we're all about. This team is really about bringing that insights to sim racing and esports because, one, we like racing and it's fun, but two, it's a fun and interesting and exciting data set that really does expose the value of Splunk in some really fun and tangible ways. And this Logitech McLaren G-Challenge broadcast analytics came out of a lot of the work that our team has been doing to, bring data out of the sim racing platforms into Splunk to drive insights. And they thought it was interesting enough to feature in the broadcast. So Matt, why don't you tell the folks a little bit about, how we got here and the why behind why data is so interesting in this context?
Yeah, absolutely. I'll start with the why. A lot happens within a race. You got cars driving around at breakneck speed, putting in driver inputs, bouncing off each other, and if it's me, occasionally bouncing off the wall. So we wanted to be able to ask questions, why that's going on, what works well, what does good look like, but present it in a slick, broadcast-ready format for the LMGC. We also harvested, curated, and collected that data so we can play it back, relive our greatest moments, and ask even more questions, which is what you're seeing on the screen now. Literally playing back 3 races, 300 metrics per car over 10 drivers, 10 times a second, so we can get these insights to you.
Fantastic. Well, so that you get an idea of what the broadcast analytics were all about, if you missed the broadcast, I'm going to share with you a quick video that shows the pre-race analytics that landed on the Logitech McLaren G-Challenge open wheel broadcast.
Gentlemen, before we start off with qualifying, we need to take a look at this data-driven insight powered by Splunk. They're going to let us know exactly what we're looking at here and how this can come into play in today's race. So, gentlemen, talk to me about this insight we have.
Well, you've got the predicted overtakes new screen there. Turn 4 is where more than likely it's going to happen down in towards turn number 5. But really what that says to me is how important your exit out of turn 2 and indeed turn 3 are with that long run. This is where you're going to be at your highest speed. Predicted incidents, turn 1. Reason being, if you run too far wide off of at turn 1, you indeed will incur a slowdown penalty and incident points as well. So it's a really fast corner, but you have to stay within the lines. So if you've got someone up your inside, side by side, that's why incidents indeed can happen there. And turn 10, it's really the last opportunity on a lap to make an overtake because it is the harshest braking zone out of the final sector. So that's why you indeed will more than likely see incidents into that corner.
And seeing data like this is also super useful to the drivers and the spectators alike, because at the end of the day, we remember the biggest crashes, right? We remember the major incidents, but that doesn't necessarily mean that's where an incident is most likely to occur on track. So being able to take a step back and just see where the drivers need to focus their attention is pretty useful.
Well, it is absolutely useful to understand what's happening in the race, not only for the drivers, and we'll talk about the ways that data can be used to make formative decisions in driving behavior, but also great for the broadcast. And after that race had completed, we actually had all 10 drivers in the open wheel final sending data to us. Again, more than 300 metrics, 10 times a second, right into Splunk. And then we provided them with some post-race analysis based on these ideas of, you know, where's the action happening? Where's the incidents happening? Incidents are where cars bump into each other, bounce off a wall. So Matt, tell us a little bit about the dashboard here that we created that was actually shown on the broadcast and what insights we can glean from it.
Yeah, absolutely. And this gets super interesting. So the questions we want to start with were, who's driving fastest in each sector? Where are the incidents and overtakes happening on the corners? So we worked out where the corners were and were able to plot up 2 dashboards summarizing this succinctly.
Do you want to tell how we got to where the corners are on the track?
Oh, God. So we get a lot of data from iRacing. What we don't have is whether they're on the corner or not. We know how far around the track they've got. So Corey helped by driving really slowly around the track, like 5 miles an hour, pressed up against the windshield, while I'd watched on a dashboard until he got to a corner and stopped. I could see what lap distance that was. So we made a lookup that would tell you whether someone was entering or exiting a corner at any point in time. It was good fun.
It was fun.
So where we're at, we took that look up. We worked out where the incidents and overtakes are, and this is Red Bull Ring. So firstly, you can see there's not many overtakes on the corners. There's a few corners where people had a bit of a stack. They hit a wall, they hit each other.
Yep.
Same for Hockenheimring. I love saying that. It's so much fun to pronounce. We're not seeing many overtakes on the corner. We are seeing a lot more incidents, especially corner 1, as people start and they're all packed up and they bounce off each
It
other.
doesn't surprise me. All turn 1 heroes are all packed up trying to make the overtake right at the starting grid. I get that.
So this raised a few questions. The overtakes aren't, except for that one corner, necessarily happening on the corner, but corners are important, right?
Yeah, for sure they are. Yeah, we got corners, are especially in open wheel competition. We got lots of corners on these complicated tracks. Navigating them, we generally say, is like the most critical activity to become a successful racer.
Exactly. If you take a corner well, you don't lose speed. You come out fast, and that's going to influence your lap time. It's going to influence your position. So the obvious question was, which corners influence us the most? I mean, how does this actually affect things?
Yeah, for sure.
What can we take back to the drivers as a teachable moment?
And that's what it's all about, is using data to try to figure out teachable moments. And that's part of the reason why the McLaren Shadow team, their esports team, has partnered with us, is to bring those insights out so that we can actually give them data-driven coaching, which if you're coming to .conf next week and you want to check out the McLaren Experiences, we actually have some of the McLaren Shadow team coaches and managers that are going to be there to coach us on how to get better at driving. So definitely check that out, because I'm pretty excited to get coached on how to get better, because currently not very good.
Some of us need it more than others. If I could learn to drive, that would probably be a good start.
Hey, maybe we'll get you a driver's license at some point based on all your sim experience.
Not a bad idea. Does that count towards my hours?
I don't think so. It's worth a try.
So what we're looking at here is getting a bit deeper into the data. So we're asking the big question. Which corners do you really need to take well to influence your lap times? So we're using something called a correlation here. If something's tightly correlated, it's strongly influenced. And for Hockenheimring, there is actually a gradient. Corner 4, there isn't a strong influence. -11 is a bit all over the place. And you can see that in the graph here. Corner 11 has a strong negative influence. If you leave that corner going fast, you're going to have a shorter lap time.
Which is good.
Exactly.
Yeah,
right?
that's what we want.
You want to win. You don't want to sort of potter around at 5 miles an hour.
No.
Now, where it got interesting, 2 things for Hockenheim specifically. Now, firstly, I would have thought having an accident on a corner would be a bad thing.
Generally speaking.
You'd think, right? And for the most part, it is. Corner 1, that corner where everyone was bunched out, turns out very, very slight correlation between having those accidents and bumping around a little bit and having better lap times. Fortune rewards aggressive drivers.
Yeah, the bold wins out there. So if you're somebody who's pressing, maybe bumping, rubbing, we talked about on Wednesday, we talked about rubbing is racing. Turns out that maybe rubbing is racing even in open wheel when they're a little bit more delicate cars.
Now, this next bit kind of made my head spin a little bit, because a short lap time, that's good. That's going to make you win. You want to drive fast.
For sure.
So you'd think the relationship between exit speed and your lap time would be the same as your relationship speed between your speed and your position.
You think?
Yeah. But no, actually turns out to be a completely different corner. Corner 12 had the strongest correlation between your exit speed and reducing your position from second to first or third to second. So crazy stuff. Something's going on there.
Really? Okay, so maybe that's the longer gap or something like that, where you have more time to close position. If you exit that one well, the exit is critically important for lap position. That's kind of interesting.
Exactly, and it's sort of coming into that final straight where you sort of lead back into those first turns again, or at least corner 13, which is a little bit behind it. So something's going on there.
Yeah, for sure. So as we start to think about, what is it that's, most important, not only for the broadcast, but for drivers, what's that sort of next stage of sort of the evolution of things that you've learned in the data that maybe didn't find their way into the broadcast and that you've kind of followed this thread of like, I wonder what else we can learn. But talk us through some of the other ideas when you follow that data science curiosity where you landed.
The joys of having an inquiring mind. So as we mentioned earlier, we were not getting very strong geospatial coordinates from the data originally. So we went and augmented that data. We didn't just look for the corners, but we looked for the world X and Y positions. And what that's enabled us to do is, well, what you're looking at here. So we can see, where people are driving fast. And lo and behold, they drive fastest in a straight line. You're straight, so where cars are quicker. Who'd have thought it?
I mean, I'm glad we have the data to prove that. I wasn't sure so far.
Well, that's actually funny you say that, because things that would appear intuitively correct aren't always. Let me show you something interesting.
Okay.
So if we're looking at, for example, brake inputs, we can very quickly plot the consensus where people on average apply brakes. And again, we're looking at them applying brakes into the corners. So that's interesting, right? We can see where most of that action occurs. Now, counterintuitively, where things get interesting is if instead of looking at the average, we look at where the data varies. So instead of where that cloud of cars has varied the braking behavior into the corners,
right.
We look at where things are most different, and we end up with these little points of space. There's a little bit of red here leading into the corner, which represents the difference between your drivers, the difference between good and bad, difference between leaders and not leaders.
Laggards.
I was trying to think of a nice.
You don't want to say the other L word.
No. So this leads into some interesting teachable moments. Recognizing those variations gives us things we can take back to the drivers to teach them to do a better lap.
For sure. And that's again, we say that's what data is about, is bringing to light things that we want to know, being able to observe an activity to optimize the outcome. That's really what we're about here.
Now, before we move on to something else that I'd really like to show you, something that came up in the broadcast earlier, which I thought was really, really cool. We don't necessarily remember the the locations on the track where incidents occur a lot. We remember the best incident.
Oh yeah, the big ones. That's what everybody's about. Like in a sport, you're looking for the big race. I think that's why people go to NASCAR races, honestly, is to watch the wrecks.
And honestly, this reflects badly on me because I did not remember the big incidents clearly. I was just toying with the data, looking at things like where body roll occurred. NASCAR, it's on those big turns, which is what you expect.
And so body roll is basically the idea of the car has some deflection left or right, forward or backward based on, acceleration inputs, whether it's turn acceleration, where I'm increasing my turn. So the car rolls to one side. So NASCAR, it looks like, clearly has quite a bit more roll, which kind of intuitive.
They're putting the suspension to good use. So they're bouncing their way around the corners. Hockenheimring, not so much. Those F1 cars are flat and they drive flat, and it's actually pretty impressive. They can do it like that. Red Bull Ring.
That doesn't look right.
Yeah, what's going on there? So I saw that and I had to recheck my search. I thought I did something wrong. Turns out I didn't. We've got what are known as outliers. Outliers are values that are so far out of left field, they skew the entire data set. And you can see very, very subtly here after that corner, we've got that little blip of red. We've got a value that is so much higher than everything else, it's making it all look blue.
Distorting the whole data set.
Body roll that is absolutely massive. Now, if I switch from average, because average is heavily influenced by outliers, they pull everything aside, and go to median, we can in fact see that Red Bull Ring and Hockenheimring, they have very, very similar body roll behaviors, similar cars, similar tracks. So what happened? Turns out someone did a flip, but they rolled and they kept rolling and they completely distorted everything else.
And so a car rolling over like this is going to create a significant value that's higher than a car slight tilting as it cambers through a corner.
Yeah, we're not talking about 5% roll. We're talking about several 360s.
Thankfully, it was a simulator. Nobody was hurt in the process. That's a good thing.
That definitely makes big difference. Although if you're going to take it as a teachable moment, not doing a flip is good for your lap time as well.
That's true. You don't need data to tell you that. But speaking of teachable moments, that's one of the things that we've worked with the McLaren Shadow team on, and frankly, it's true on in sports, F1 in real life, but any racing series is how do we use the data to help the drivers go faster? It's all about those inputs. Yes, we can use data to make informed decisions on pit strategy, on tire strategy, but yeah, driver inputs is pretty critically important. That when you get out of that race car, you want to understand, where do I fit in the pack? How am I performing against my peers? And how do I get better? So show us a little bit about what you did there that you think you can use to help.
Yeah, absolutely. And to your point, there is a little bit of variation in the performance and setup of the Formula One cars, but the biggest variation is the driver you stick in them.
Mm-hmm.
And the first thing that turned out to me is when we divide up the track into little 100-meter segments,
Mm-hmm.
it is very rare to have a race where one driver got the top speed and the best performance over each segment. The different personalities, the different input styles lead with different people excelling at different points in the track. And that's what we can see here. The track divided by who was the most awesome at driving that section of track.
So you basically cut the track into, instead of sectors, cut it into 100-meter segments.
Yep.
And basically who is going the fastest in that 100-meter segment as an overall, like in that segment, I'm the owner of being the fastest. That's what that's showing me.
Exactly. So the people who actually had a knack for a particular part of the track.
Mm-hmm.
And you can usually expect with a race, there will be some part of the track everyone excels at.
Mm-hmm.
Now, the interesting thing there is if we look at those segments that someone's driven super fast and then look at the next segment and make sure they didn't drive super fast into a wall or into the crowd, because that's not good.
Yeah.
We can actually start stitching that together. And that's what we've got here. The fastest segments of every track, along with the driver inputs that resulted in those fast segments,
Mm-hmm.
that didn't result in a crash. And what we can do is take this theoretical perfect Franken lap
Mm-hmm.
and compare it to people's laps as they're racing and say, okay, so you drove it very close to the theoretical perfect. But if you tapped the brake a little bit later or accelerated just a little earlier coming out of that turn, you can improve your performance. And we can take all of this data and relate it to those lap times because we've got it all in one place.
That's brilliant. So that's the beautiful idea, is that we can take data that tells us, hey, if you brake a little later, brake a little earlier, brake a little harder, turn in sooner, turn in more aggressively, those points, you can actually go back in the footage and see the drivers who did this in the optimal scenario.
Mm-hmm.
And maybe it's things like, during practice, drivers, a lot of times when they get on track, what they're doing is they approach turns is they're trying to find visual cues that tell them when an input is necessary. So at what point on what braking marker do I want to be aggressively in the brakes? And so being able to take this and correlate it with video data of who's doing it the right way best, what an incredibly powerful teachable moment. So thank you for that, Matt. And honestly, that's the story that we're painting here for all the folks that are, wondering, like, why is Splunk so interested in esports and sim racing? And it's that, candidly, data sets like this are fun, interesting, intuitive to understand. They give us an opportunity to get hands-on with a platform like Splunk and Splunk Observability Cloud to solve some challenges with fun and interesting data that absolutely the skills that we develop to achieve objectives like this are absolutely applicable in our day jobs as practitioners in IT operations and observability. So we encourage you to tinker, learn, be curious, and follow that curiosity, because clearly you can follow it to some pretty interesting findings beyond what the questions you took up front were going to be.
I think that's the biggest take home, not just with this data, but any data set. The questions you think you have when you start and not the questions you end up needing to answer. And being able to pivot and find what the actual questions are is so much more valuable than just seeking answers from the start.
Well, fantastic. Well, if you want to get your hands on this data and on Splunk's incredible technology, we encourage you to sign up for Boss of Ops and Observability happening on Monday. That's June 13th at 6 p.m. Pacific time. You can sign up at boo.splunk.com, and that is going to be your best chance basically throughout the year to get hands-on with Splunk. Again, there's going to be some cool episodes around observability, cloud migration, application modernization, connecting outages to business impacts that are real-life scenarios that you'll get a chance to solve as if you're ace working for the Splunk t-shirt company. But you're also, thanks to Matt and team, going to get a chance to get hands-on with this Logitech McLaren G-Challenge data set from the finals this past year. See some of these dashboards, interact with them, and answer some questions. We definitely encourage you to sign up at boo.splunk.com to do that. And hopefully we'll see you at .conf next week, where we have some fantastic McLaren experiences, some McLaren simulators, and a bunch of really great sessions being led by folks from McLaren and Splunk, connecting the dots between data into doing platform like Splunk and how it impacts racing, and frankly, trying to make the world a better place. So Matt, thank you so much. It's been a fun series to go deep into the mind behind the broadcast analytics. I really appreciate all your work on this,
It's
man.
been a seriously fun opportunity, and I'm sure if anything, my driving ability can only improve as a result of this.
That's right. Well, I'll tell you what, my enjoyment when working with you has been fantastic. I do encourage you all, stay curious, get out there and learn as much as you can, get hands-on with Splunk at Boss of Ops and Observability next week. And as we always say, whatever you're into, be data-driven and join Data Drivers.